Got it? Okay. Hello. Hello, IIMT. Myself Sanjay Yadav from IIMT College of Pharmacy as an associate professor, and I have just completed chemistry in pharmaceutical chemistry. So today, just we are going to discuss in brief about acid-base titration. So for diploma, for degree, it is a beneficial for you all. So today, just I had select a simple topic, that is acid-base titration. So in that, here before going to start in detail, uh, just a second. Okay. Here you can see here what is the acid-base titration. So in that, all you should to know the acids means that contains a hydrogen ion, that is HCl, concentrated H2SO4, and nitric acid, they comes under acid, and bases like that. So here we are going to, before start this acid base titration, you should to know what is the acid base titration. So today I had just select a definition about acid base titration. So it is a method of quantitative analysis for determining the concentration of an acid or a base by exactly neutralizing it with standard solution of a base or acid having known concentration. Okay, so here why we are introduced, or why we are just give the definition is a method quantitative, because we had select a quantity, how much quantity we are going to check after neutralizing. Neutralizing means, suppose we have taken a acid, then we go for titrate against base by using different indicators. So it has different, like acid base titration means strong acid, weak base, strong acid is strong base, weak acid is strong base, and weak acid, weak base. Like these four types of acid base titration we have. So in this, you can see here indicator choice means we have a different indicator, either acidic or basic phases we are going to adopt. So in that, you can see here a suitable pH indicator we have and chosen in order to detect the endpoint. Endpoint means either in the form of color change, that is, suppose previously or initially, suppose we have a colorless compound after just addition of indicator, then after endpoint it will neutralize and sudden changes to color, or it produce a color like pink color or purple color, depend on compounds or depend on acid base titration reaction. So in that, here you can see here a strong acid suppose will react with strong base, then exact result we can see at pH 7, that already we have to know 7 pH 7, that is neutralized. After neutralized, it will give a sharp endpoint, or you can say it gives good result, because ionization in a strong acid as well as a strong base can easily uh, see. So reaction, it will completed after neutralization, it will give a color. And second one you can see here, strong acid suppose will react with a weak base, then definitely not complete neutralized. So below 7 pH, it will give a color. So you can say it is a end point of this acid base titration, like a strong acid versus weak base. Whereas in this way, weak acid and strong base, suppose we are going to reverse. So in that case, pH, that is 7 is a neutral one, but more than 7, it will give a color. So this three is very important. And fourth one, just let it be discuss about weak acid versus weak base. So there will be no indicator, as you know, because it's a rare reaction can occur. So there will be no indicator available for that reaction. So here we are just will discuss about strong acid strong base, strong acid weak base, as well as weak acid strong base. So these three are easily can go for acid base titration, and at Neutralizing point will give a sharp color, or you can say it gives a color changes. So we can say is a end point. Okay. So in this series, we are just going to just no need to explain every time theory and okay. This with the help of this image, that is animation, this one. So here you can see in a conical flask, acid-base titration, like strong acid versus strong base. We are using phenolphthalein as an indicator. So at the end point, they give a pink color. So we can say, okay, and titration is completed, and then uh, at this pH will give the result. So in that, here titration with the base titrant. One more image I have. I will just uh, this share with you, and just okay. Here one more image. Okay, so here we can see this diagram. One more acid and bases. Suppose in base just taken in a conical flask and acid is taken in a burette. So in that case, we are using phenolphthalein as an indicator. Acid, here we are going to take, you can see here, a titration curve we plot against. There is typically the titrant is a strong dissociated with acid or a base, such as curve used are useful for determining in point and dissociation constant of a weak acid versus weak base. So here you can see a strong acid versus strong base titration curve. We can see we plot a pH against a volume of NaOH added. So in this titration, NaOH as a titrant we are taken in a burette, and acid as a titrant taken in a conical flask. So after addition of a phenolphthalein indicator, it will give same. There is no color, and after addition of this NaOH like 10 ml, 20, 30. So likewise, pH will increase slightly. You can just see here in a acid-base titration curve. So at the end point, that is pH 7 equivalence point is reached, then color will change. That is from colorless to colored compound. Suppose a phenolphthalein indicator I am used in this acid-base titration. So likewise, this feature of this strong acid is strong base already here we are with the help of plot a graph means pH against NaOH we are already discussed and see the things, and in this way here the pH starts out low, reflecting the high hydronium ion of the strong acid and increases gradually as acid is neutralized by the addition of base. Same thing in the previous one images you can see here after addition of NaOH in a acid solution. So gradually pH increases, and at the end point, that is whenever it reach at 7, it gives a color, or you can say color change. Okay, so in this way we can plot a graph against strong acid, strong base. You can see here strong acid and strong base. They give a good result, or you can say good end point or sharp end point. So we can see here. So in this way, suddenly the pH rises steeply. है ना? Already we are saying on with the help of this detail, this occur in immediate vicinity of the equivalence point. So previous one here you can see here after reaching a end point or equivalence point, it will drastically increases, and then you can see with this plot. So we can say strong acid versus strong base is a very easy method and can see with the help of plot. So here are so many calculation like problem. Suppose problem is we are solving like 40 ml of zero point 0.1 molar HCl against zero point 0.1 molar NaOH. Here strong acid and strong base. So here a calculation part. So we can see initial moles of hydronium ion. We can just see with the help of diagram, or we can say with the help of tables, where we can say serial number, initial reading, final reading, and concurrent reading, or you can say average reading, and finally we are going to calculate and concurrent reading we can uh, got, that is with the help of N1V1 and 2V2 formula is there. So here the standard formula where hydronium ion concentration is equal to amount of a hydronium ion remaining, that is in a base, in a bottom conical flask, where original volume of a acid and volume of a added base are already present. Added base, that is how much base already added, and original volume of acid means how much acid they are going to neutralize. So this way we can see, and then go for next one, like suppose the second query, if equivalence point after adding 40 ml of zero point 0.1 molar NaOH. So likewise, first we are going to add 20%, that is you can say out of 40 ml we are going to add 50%, so it will reach approx half of the equivalence point, and ultimately 40 ml added, finally they're going to neutralize. And here again formula you can see here, hydronium ion is equivalent to, again same formula, going to amount of hydronium ion remaining and upon original volume of a acid and volume of added base. So these are the simple formula. So we can just plot a graph and just make a table, and where from where we can just take a readings, and whatever we you are going to perform, then enter in this formula, and we can got a result, that is quantitatively. And here also after the equivalence point, third point means after equivalence, when starts color change, initial to final, that is after adding 50 ml. So here we can say 40 ml already added, then become the completed the reaction, then again go for adding more 10 ml of this NaOH solution against zero point 0.1 molar NaOH. Then in that case, again formula is converted, means after neutralization they are going to convert into basic form. So here hydronium ion they are converted into hydroxide ions, and again formula here you can say amount of hydroxide remaining on a original volume of a acid, where volume of added base are calculated. So in this way, you can see here with the help of plot, means NaOH against pH, we can see first gradually increases till end point. It is an acidic condition, and after end point, they are going to convert it into basic. We can calculate hydroxide ion present in that given solution or that given sample. So in this way, next one you can see here. Suppose we are going to take a weak acid, weak base, then how can see, how can say this previous one plot and this one plot is differ. So here you can see simple. Again, I am taking NaOH solution against pH, that is again going to perform, and here 40 ml again leads for neutralization. But previous one already I told you, the weak acid suppose titrate against a strong base. So in that case, it converted into, means it will increase after 7 pH. It increase pH 7. Then here you can see here pH that indicates 8.8. So here then phenolphthalein gives a color, that is a pink color compound. So here you can see, suppose weak acid we are going to treat against a strong base, definitely pH will increase in place of 7. So here buffer region that means this is standard one, that is started from 1 pH 1, but now it will start from 2 point something, because weak acid but natural. Strong acid means they attract, or they are very strong to just attract it towards. So in that case, it will increase pH in place of 7, 8.8 at a equivalence point. So here you can see here, see equivalence point in a strong base versus strong acid, they give equivalence point, that is pH 7, but here they are giving 8.8 because strong base is present here and they are going to perform at 8.8. So there will be color change. So here you can see here four major differences between a strong acid strong base titration curve and a weak acid strong base titration curve. Yeah. What is the difference actually? These two titrations. Here you can see these are the 3 to 4 points. We can see here, that is initial pH is higher. Where initial pH is higher means in a weak base, and weak base versus a strong weak acid versus a strong base. So initial pH is a higher, you can see in a previous one graph. So in that, a gradually rising portion of the curve called buffer region. Definitely you can see here in a previous one slide. So जो buffers है, whatever the buffers is there, buffers in the sense in place of pH 2 they are going to increase, that is 4 or 2.5 or whatever. We depend on quality of a product, whatever we provided, and appears before the steep rise the equivalence point. So we can see in a strong base versus strong acid, they have a pH initial one, that is pH 1, but here a buffer it will take in weak acid strong base, that will increase in place of pH 1 to 2.5. So in that case we can see automatically in place of 7 neutral point is there, that is a pH 7 for strong acid strong base. Here is a change means already buffer it will take like 2.5. So automatically they will increase in place of 7, that is 8.8 or 9 it may occur. So these are the major issue with this weak acid strong base, and the pH at equivalence point is greater than 7. Definitely more than 7 in a weak acid strong base. Steep rise interval is less pronounced. Definitely is a less pronounced because sharp in point it will pH 7. Okay. So here we can see with the help of problem, or you can say with the help of questionnaires. So we can see, consider the titration of 40 ml. We are talking about weak acid strong base. So here you can see weak acid, that is we are taking acetic acid, we have just taken in place of HCl, and strong base as usual NaOH. So we had prepared zero point 0.1 molar NaOH solution as well as zero point 0.1 molar acetic acid solution. So here reason 1, solution of weak acid to be titrated before any base is added to this one. So for you I have a question, so just raise it. And similarly, suppose we are going to perform weak acid versus strong base. So consider the titration of 40 ml of a zero point 0.1 molar acetic acid with the 0.1 molar sodium hydroxide. So in that, after 30 ml of base has been added, this is a clearly in the buffer region of the titration curve. Clearly in the buffer region titration curve means previous one already I told you, and already I had to share with all details, because buffering means is a weak acid. So after addition of this acid in a strong base, so definitely it pull out towards on. So ultimately we can see the buffer means pH 1, they are going to change with the pH 2.5. So here in a next slide we will discuss in a brief about weak acid and a strong base. Okay, so here you can see sample calculation. There is a strong acid already told you, and then next one, this one. Okay, okay. Here a pH range of acid base indicators. So here we can see a different pH range. We have a different compounds or indicators we are using. That is for crystal violet, you can see here you see for 0 to 2, maximum 1.9 or 1.8 we can see here. Thymol blue, that is from 2 to 3, and dinitrophenol 2, 4 dinitrophenol we can see here 3 to 4, bromophenol blue 4 to 5, bromochrysal green. So likewise, different indicators and so many indicators we have for acid-base titration. So someone like bromothymol blue, already they are give a indi point or equivalence point, that is in between 6 to 7. Phenol red will beyond the 7, that is 7 to 8. Phenolphthalein, that will slightly 8 to 9. In between they give a good end point. And alizarin yellow red, so they give a 10 to 12 pH. In between they give a end point, or you can say equivalent point. So where we can use as per strong acid weak base, or weak acid is strong base, or weak base is strong acid. Okay, so these all have a three different types of acid base titration, where different indicators we are using. But nowadays, in a lab, regularly we are using like strong base, acid strong base. We are using phenolphthalein as an indicator because it gives a good result at pH 7. And then go for weak acid strong base. We are using methyl orange, methyl red, crystal violet, phenol red. Different indicators we have. So uh, depend on character, or depend on this compound activity or a response, we are using different indicator. So here you can say now we have this different pH ranges. So in a previous one, just go to fast review and fast brief regarding this acid base titration. So okay, so final we are going to just summarize and concluded that why we are taking a acid base titration. So ultimately we are going to just previous one in a very first slide we had already shared in a definition, that is qualitative, that is quantitative analysis for determination. Okay, so here we are going to discuss about the quantity means how much amount, or how much acid, or how much base they are going to be neutralized in the presence of indicator. So here we can see, and we can see the things, the compound like strong acid or a strong base, when we are going to add indicator. So with the help of formula already uh, shared with you all here, we can see different calculation is there. So calculation here, like suppose below pH 7, we can go for a calculate with the hydronium ion concentration, and we'll go for next one, that is after pH 7, it will calculate it by hydroxide ion concentration. So where we can calculate, we can just find out the readings, amount they are going to absorb or amount are going to be neutralized with other one. That means suppose we are going to take a acid in a burette. So burette in that is titrant, and NaOH solution that is taken in a beaker, that is titrant. So after this reaction or after this titration, I have a different reading, like initial reading started from a 0 and will go for just 20 ml addition, adding. So it will reach near about 50%, and then after 40 ml of this titrate, 40 ml of this concentration or solution adding, then it leads for neutralization. Neutralization means ultimately we can say color changes. And color changes, that means we can conclude that okay, we had find the solution. So in this way we can go for a strong acid, weak base, strong acid is strong base, weak acid is strong base, can easily calculate, or you can say in a lab we can perform, and we are very different kind of compounds, like a strong acid like HCl we can use here in place of concentrated HCl. We can replace with the concentrated sulfuric acid, or you can replace with a nitric acid, concentrated nitric acid. Likewise, go for a strong base, so we can choose a concentrated NaOH solution. Okay, weak base, we can go for ammonium hydroxide. So likewise, we have a different concentrated compound in the form of a strong acid or a weak base, strong base or a weak base. So in that case, we have a different types of acid base concentration. So here we can go for just taking one by one, like a strong acid, strong base. So here we can conclude that, and in lab we can perform. So with the help of tables, table in the sense like a starting initial reading, final reading, average. So we can go for three readings, uh, five readings. So depend on that performance. Suppose we will go for suppose it will not give a good result, or you can say with a minor difference between first, second, third reading, then go for fourth one and fifth one. So we can just out of this five, we can just go for concurrent reading. So we can see there any two readings nearby each other, so we can take. Okay, so suppose we'll go for with the help of example. Suppose starting with the initial reading is a 0, and we got a reading 25, and then go for again second reading for a initial, that is 25 is the initial one, then go for 48 or 52, like that. So go for third, fourth, fifth reading. So in that we can just select best two readings nearby each other. So with this, I had conclude my topic, and in future we'll just try to implement, and we'll just go for with this new topic. We will meet you next time.